Is done? Yeah. Keep what you written. We will see. We will see about what is manufacturing process. Okay. In this slide, this picture about manufacturing process. Do you consider this picture as manufacturing?
Yes, sir.
And how about this?
Uh, I
No?
think yes.
Why? Is there any difference between first picture, previous slide, and this slide?
The first slide, the product or the goods are produced by a machine, which is controlled by a human or man machine. But the second slide, it's more into crafting a product or goods that is made by a man,
Human, okay.
a human.
Anyone else? But your opinion about previous slide and this slide?
I think it's the same aspect where we create the output based on human or user needs or requirement.
Anyone? Others? Or you can identify what is or what is the main difference between the previous slide and the current slide.
The main difference is for the first slide, they are using a machine like Fadil said, and the other one is handmade.
And maybe another aspect, is there any difference
Maybe mass production.
about mass production?
Yes.
Okay. Yeah. First of all, if we want to identify whether this one is manufacturing process or this one is manufacturing process, both of them are manufacturing process. The main difference is the first slide, the goods are made by machines, and the second one, the goods are made by human. But if both of this picture are produced in mass production, we can say that both of them are manufacturing process. But if this picture, the production process, only made one or two, we can say that we cannot say that this is a manufacturing process. Okay. That's when we want to know if the activity or manufacturing process considered as a manufacturing process or not, we can look at the production volume. Production volume. Okay. So manufacturing process or manufacture is derived from Latin language. It means manus and factus make. Yeah. In the past, manufacturing only made by people, only human. But nowadays we have technologies, so we can use machine technologies to create objects or goods. So you can check your definition, what you written about manufacturing process, and check if it's fit with this definition. Which one is more fit with your opinion? College Dictionary, Science Foundation Workshop, or the Gagu? or you combine all of these three into one definition.
I think my definition is more into the college dictionary.
College dictionary.
Yeah.
Examples of players, criminology, machinery, especially on a large scale.
And also the verb.
Added value. Added value.
Added value.
Added value. So manufacturing usually you transform raw materials into semi-finished goods or finished goods with added value, and you using integrated information, human technology efficiently. Okay. So have you learned about material science and engineering?
Yes.
Previous semester.
Engineering material.
Yeah. Engineering material or material science and engineering in previous semester, right?
Yes.
Is material a essential part for manufacturing process? Yes. What do you know about material? You already learned about material, and I want to know what do you know about material and its role in manufacturing process.
Maybe it's about the foundation of the finished goods, where each material has its own brittle or strain
Properties.
properties.
Okay, go on. What else? You can use this picture to explain the role of material.
Okay. So in my opinion, raw material is a substance that is helped to produce the finished part, or also the unfinished part that is going by through like manufacturing process by the machine or maybe labor.
Maybe you ever heard about 5Ms?
Yes.
Yes, 5Ms. Material,
Material,
man,
machine, money, method.
method. Okay. So material is one of these five inputs. Input to where manufacturing process is process to transform. Yeah, to transform raw material into finished or unfinished parts. So manufacturing process, it have products, two kind of products, intended products and unintended products. So unintended products we used to call byproduct or scrap or waste. Okay. So can you explain about this picture? Material have attributes, namely physical, mechanical, thermal, electrical, environmental, economic properties. And they will go through processes. Some processes will have shape and then different shape have a different function. Can you explain about this? Have you learned about heat treatment process? Cold working process, hot working process. It will affect material properties.
Yes.
Can you arrange? Maybe mechanical attributes. Start from mechanical attributes. Can you give an example if we perform different process? How different process can affect material changes in material attributes, especially mechanical material. You said before about brittle, ductile. How different process, hot working process maybe, or cold working process can change the material mechanical attributes.
Maybe but for the hot working process, from the heat treatment,
Heat?
heat treatment,
Heat treatment.
yeah,
Heat treatment.
from the hot working process, the process will affect the shape because from substance, if we give a high temperature, it will of course make the shape into more elastical, and also the function is different. And from the cold working, it's more into making the shape or the substance into hardening.
Hardening.
Yeah.
Okay. Can you explain what are difference between hot working process and cold working process?
Maybe for cold working process is the process of
Heat treatment.
heat treatment under the crystallized temperature. And
Recrystallization.
crystallization, and it works for sharpening the metals, for example. From hot working, it makes like the shape. It's make it easier to reshape the material, but it is very hard and not smooth for the cold. Its function is for sharpening the metal after the shaping. If that makes sense.
Okay, so cold working process, as you mentioned before, it's a heat treatment process under
Under
recrystallization temperature.
Yes.
And on the other hand, hot working process, a heat treatment process that above the recrystallization process. So, what is the difference when we see from the form of the material itself? Cold working process, the material is the material transformed from maybe transform into liquid form, or hot process or hot working process, the material transform to liquid form.
I think the hot working.
Hot process.
Yes.
Hot working process transform into liquid forms. Okay. So when we choose material as one of the important inputs for manufacturing process, we have to consider 4 items. Yeah. First is performance, properties, processing, and structure. As you already learned in previous semester. So this one. When we choose material for manufacturing process, for the example automobile manufacturing, we always consider about performance divided by cost. Performance divided by cost, and from this performance divided by cost, it will we will have some questions to answer. So the answer will explain about composition, synthesis, and processing, and the last one is microstructure. So these are the question about performance per cost. What is the strength to density ratio? We use automobile manufacturing as an example. What type of car do you want to buy, or do you want to produce in nowadays? If you have money, you want to make a automobile manufacturing, what type of car do you want to produce based on strength to density ratio? Do you want a car that have good strength but heavy, or the opposite? Low in weight, low in strength, but lightweight. Maybe we can compare, muscle car produced by Americans. Yeah. What are the characteristics of a muscle car? Heavy. How about strength? Strength means when we do a crash test, what are the strength of the car, muscle car?
It's durable.
Durable. Hard to deform. The material is hard to deform when have an impact. How about density? Heavy. Density. Is density similar to linear to material or object weight?
Yes.
Yes. Why?
Because maybe for me, if the material as the dense material now is tungsten, maybe if is compared with same size, maybe tungsten aluminum is more lightweight because it's not as dense, but aluminum is easy to deform and tungsten is not.
Okay, maybe we can start from what is density. Very simple explanation about what is density. The gap between particle is
dense.
what? Another word for dense.
Compact.
Compact means high density or low density. The gap between its particle closer means
Higher
density. Okay, so why density can affect object or material weight?
There's more particle
More particle.
and in the same size.
Mhm. In the same size,
There's
high density material have got more particle, yeah, compared to material with low density. So back to what I asked before, what is the strength to density ratio do you want if you have an opportunity to maybe buy a car or produce a car?
Well, maybe if it's possible for the real world, maybe we have ideally made for like hard strength but less dense, if that's possible in the real world. Yeah, so the material has to be maybe less dense, so it is more lighter, but it's hard at the same time, if that's possible.
Okay, that's some ideally,
Ideally,
But can you identify why muscle car or car produced in before 2000, maybe before 2000 is more heavier than car produced after 20th century?
maybe different in material and making the body and the chassis.
No?
Maybe
Because of the
maybe a difference in the manufacturing process. The process when they process the material is different from before the 20th century and right now.
About technologies they use or
If the technology they use.
okay, another?
I think because of the how big is the machine back then. How big is the machine? From the late 2000, more into like 5,000 liter, like 6.2. But now the machine is more light, and then even we have also hybrid machine and electrical, something like
Okay.
that.
What is the root cause of the changing of size of the machine?
Like
Root cause. Have you ever heard about horsepower? Yes, horsepower. Horsepower and machine volume. CC. Yeah, CC. What kind of factors that made manufacturing to change the size of the machine, the volume of the machine from maybe 6,000 cc to 1,000 and I think and 1,300 cc.
lower the cost. To
Lower the cost.
Yeah,
Lower the cost for consumer.
yeah, for consumer because of the gas price. Maybe.
Gas price. Yeah, gas price. Gas price. Gas is abundance in the 1980. and the price is low, and after crisis, the price is going high. Gasoline price is going high, and it make manufacturing to rethinking. They have to lower the volume of the machine, so consumer can buy the car, and they don't have to buy a lot of gasoline for their activity. Okay. How about the formability? If we choose high strength, it means the material is more difficult to transform from one shape to another shape. If we choose aluminum, for example, less density, a lot of room between particle, so the material is more easier to deform. So which one? If we choose high strength material, it's more difficult to transform from one shape to another shape. So it means we have to spend a lot of time, more time, to transformation process, for transformation process, and the cost is high, and we use a lot of energy to do the process. Okay. The third question: how does this relate to the crashworthiness of the vehicle?
I think if you pick a car with a very dense material, when the car crashes, there's no, it's called crumple zone. For example, if the car get hit by the front, if the front is deformed, it can absorb the impact and it will not affect the driver.
The last one: what is the cost of fabrication? What is the cost of fabrication? Already explained on what is the formability. The effect of its material is more easier or difficult to transform from one shape to another shape, so it will cost the fabrication in overall. Yeah. Based on what? First is time consumed, and then energy. And then also cost, energy, time. How about tools or equipment? Which part of the tools and equipment affecting the formability of the material? Which part of the tools? For example, milling machine. Or have you maybe you I believe you familiar with cutter. Cutter. Yeah. It's one of cutting tools, yeah, one type of cutting tools. They have
A point to,
yeah. So if we trying to cut hard material, the tip will be dull. We have to change. Yeah, we have to break it, and so that kind of part of cutting tools will dull more easily if we try to use material that have low formability. Yeah, okay. So according to these questions about the composition, which type of car do you want to produce? Iron based or aluminum based?
Aluminum.
Or maybe for today or people in your generation, which kind of car do you want to buy? Iron based car or aluminum based car?
Aluminum maybe the best choice.
Aluminum
Yes.
and alloying elements. What do you want? What another material you want to add to the aluminum based? The fiber is okay.
Carbon fiber.
Fiber.
Yes.
So there. But aluminium is lightweight. Carbon fiber is lightweight.
Lightweight.
Aluminium based, it means if we you can see what quantities. If we create a car with 70% aluminum and 30% iron,
Next.
what properties you get from that combination? 70 aluminum, 30 iron, or 70% iron and 30% aluminum. Iron 70, aluminum 30, aluminum 70, iron 30. Which one?
Aluminum 70.
Aluminum 70, iron 30. Why? Aluminum 70 means the car is lightweight, but not as weak as 100% aluminum. Okay. How about synthesis and processing? How can the steel making be controlled so as to provide a high level of toughness and formability? You already learned from material science, material engineering, about heat treatment process. Okay. Microstructure. What features of the structure limit the strength and formability? You already learned about material defects. Some defects are essential. Some defects have positive impact, and some defects have negative impact for the strength of the material. So maybe you can remember what are the positive defects.
Maybe for example in the oil rig company, they use like an outer layer for corrosion.
Outer layer
It acts-
corrosion.
It acts for protection from the inner layer. For example, like zinc.
Zinc.
Yes,
In
the water oil. That's a positive impact.
Sacrificial anode.
Sacrificial.
Sacrificial anode. No, I mean kind of defect. What type of defect have a positive impact on material strength? What type of material defect will have positive impact on material strength? Sacrificial animal is a method, right?
Yes.
It's a method. But what type of material defects have positive impacts on material strength? Maybe for this composition, aluminum based 70% aluminum and 30% iron. How the method to combine this kind of material into one material? You stand up or you have another method?
Maybe melting.
Melting? What working process? Above recrystallization temperature? What is defect?
Weakness.
Weakness. Okay. Another term. What is defect? Now, what is the opposite terms of defect? Opposite terms of defect. Defect something with weakness. The opposite.
Strength.
Strength, the opposite of weakness. Defect. Perfect. A product without weakness. Product without weakness, a material without weakness, material with defects, product with defects. Defects material, perfect materials. brittle. No. Brittle is material properties.
But does it count as, for example, titanium if it can withstand heat very long, so after it heats and it cools down, the material become more brittle than before.
Mm-hmm. Yeah, it changes in properties.
Maybe metal corrosion, like this metal chair.
Mm-hmm.
If it's stand with oxygen with too long and it becomes corrodes.
Mm-hmm. So,
That's
in corrosion phenomenon, when we see from the material structure, what is actually going on there?
deform.
Deform. So the material, the iron material became the structure of chair is made from you can say iron,
Okay.
100% iron. When the iron is corroded, there will be another material replace the iron material. So what we call that condition?
Inclusion.
100% iron became maybe 95, 85.
Is it inclusion?
Hmm?
Inclusion.
Inclusion?
That unwanted non-metallic or foreign particles embed in the material.
Okay. 100 iron materials, we can say that the structure of the chair is made from pure 100 pure iron, yeah, pure iron. It means 100 iron particle. But if the structure is corroded, another particle will replace the iron material. So it became from pure to pure means the material is perfect, 100% perfect material.
Defect. Become defect.
Defect. You can say the opposite of pure is
Defect.
Defect.
impurities. Yeah, impurities. The impurities of the material will determine whether the material will have more strength or less strength. So, the one type of positive effect of defect in material, we can you already learn about substitutional and interstitial defects. What is substitutional and what is interstitial? You explained before about hot working process, the process of heat treatment of material above recrystallization temperature. It means that material will be melted and it made easier to adding another material into one new material. You cannot just pile up iron and aluminum, zinc into one material, but we have to melt it. So the phenomenon is when aluminum and iron have different temperature to transform from fluid form to hard form. Aluminum will be transformed from fluid to hard form maybe at 800 Celsius. But melting point. But iron maybe at 500. Maybe, yeah. So the vacant spot will be replaced by another material that have fluid form. So positive effect, material defect that have positive effect on material strength, substitutional defect and interstitial defect. How about negative? What type of material defect would have negative impact on material strength?
Probably like the dimension cracking.
Dimension cracking.
Corrosion.
Corrosion.
Maybe one.
Impurities. Vacancy. What else? Substitutional is a positive type of material defects. Okay. You ever seen this before? Really? Material science? Material engineering? First meeting?
Maybe yes, but I think it's not really important, so I think he just skips.
Actually, this one is very important. Yeah, material selection. Some students ask, what is the relevance of we studied material science in industrial engineering? Because material science is one of the subject of mechanical engineering, and it's quite different between. It's not quite different, very different, between industrial engineering and mechanical engineering. Why we need to study material selection or material engineering in industrial engineering? You studied about product design already? Product design? Not yet?
Not yet, yeah.
Not yet.
Yeah.
Okay. So in industrial, we can say that if we want to solve the problem from the system, and one kind of solution that we can give to solve the problem is create a product. To solve the problem, we can create the product to solve the problem. So it will you will study about product design. In the first section, you can see design requirements. If we want to create a product, it have to based on problem. You can't just create a problem sorry, you cannot just create a product, or you cannot just give a solution without a problem. So if we want to solve some problem, for example, motorcycle, safety on motorcycle. In the safety of motorcycle, we can you identify what kind of problem you want to solve in motorcycle? Maybe helmet. Helmet is created to give safety for motorcycle rider. So you will create a product based on the problem that arises in society. So design requirements. You want to create safety tools or safety equipment that can guarantee that a motorcycle rider can drive safely. Yeah, he can drive safely. Helmet protects our skull. Yeah, our skull. Protect our skull. So, if you want to create some product, in this case helmet, that can give rider safety, protect their skull, what kind of property required property profile, what kind of property you want to present in your product, in this case helmet. What kind of property? Maybe we can say only from mechanical properties only. We can neglect all the electrical, thermal, focus on mechanical properties. What kind of properties have to present on your product? Durability, comfortability, maybe from the visor. The visor have to the rider can see through the visor.
Yeah.
Okay. What is the terms for that?
Visibility.
Visibility. And then? Okay. Start from visibility. If the visor have to, the rider can see through the visor for visibility, what kind of material available?
Plastic.
Glasses.
Glass.
If the constraint only visibility,
I think.
glass is okay.
I
Yes.
think
Glass okay.
dangerous.
The context is if we want the material, if we want the rider can see through the visor, so plastic is okay. Glasses okay. Another material, plastic, glasses, glass, metal, no. Elastomer, no. Okay, glass, okay, plastic, okay. We add another constraint. Visor must be lightweight. So we eliminate glass. Okay, so that is one of the process of material selection. If only one constraint, so we have a lot of alternatives for material we can use to produce goods. Okay. So based on required property profile, and then the other consideration is required shape. The skull protector or helmet. What kind of shape you want to? It's possible to protect your skull.
Round.
Round, square.
No.
Why? Square helmet? Yeah. Yeah, it's protect. Outer shape is square, but the inside is round.
Yeah.
Just fit for regular skull. But the outer is the more important. Yeah, the outer is the more important. So round is okay, square okay. Triangle.
Sure.
Okay. Yeah, it can harm people too. Another shape maybe?
Oval, maybe.
Oval? Okay. So basically, to protect the skull, every shape is okay. Every shape is okay, but if we add another constraint, maybe aesthetic, yeah, aesthetic or formability, can we shape plastic into round shape, square shape, triangle? Okay. What kind of material to protect our skull? Maybe the motorcycle. The best material is metal. Yeah, the best material is metal. Its strength is unquestionable. Wood? Okay, protect our skull. Wood. Oh, elastomer. Rubber.
Yes.
Okay. Glass. In some case, can.
Yeah.
In some case. Another material? Another material?
Titanium.
Metal. Yeah. Okay, so basically, every material that available for engineering purposes is available to protect our skull. But when we add another constraint, we want helmet that have lightweight, safely impact in high speed. Another constraint, it will limit our choices. It will limit our choices. Okay. So manufacturing process you already write in your paper, and manufacturing process you can say that it's an activity of transforming raw materials or semi-finished material into other forms with added value, utilizing machine, tools, methods, and human labor. So what is the difference between process versus manufacturing process versus manufacturing system? what is manufacturing process and what is manufacturing system. So you can see this picture is manufacturing
Process
system.
system.
This picture is manufacturing system. Manufacturing process is only this one, individually. Individually. But manufacturing system is integration. All these steps into one. System is integration. Okay. So what will you learn in the journey of our manufacturing process subjects? Next week we will study about casting and molding, and then forming and metal working process, machining, material removal process, joining, assembly, surface treatment, and heat treatment. You already learned in material engineering. And then on manufacturing process, in general process, we have two type of process. Mainly we have, in general, we have two kind of process. One is primary process and second one is secondary process. What is the difference between primary process and secondary process? Primary process, casting, forging, extrusion, sheet metal working process, cutting, machining. Secondary process, fastener, adhesive, joining, coating. What is the difference?
Maybe for primary process is based on user needs, and the secondary process acts as a feature maybe.
User needs.
Yes.
What do you mean by user needs? Can you elaborate?
Maybe if we took an example for the helmet, our main purpose is to save back as for safety. So that means we have to make the process based on that need, which is the main purpose. But for the secondary process, in my opinion, is for the features on it.
Features. Can we say that based on what you explained, a user do not need secondary process?
I don't know.
So you put a helmet and you assemble it on your own. You want kind of that kind of helmet? Buy separately. You buy the skull protector, you buy the strap, you buy the visor, and going home and assembly it on your own. So, what kind of difference between primary process and secondary process? Primary process, you can see the type of primary process are casting, forging, extrusion, sheet metal working, cutting, machining. Secondary, fasteners, adhesive, joining, coating. Can you identify what is the difference between primary and secondary?
I think in this process part, we have like the primary process and also the secondary process, right? So the primary process is the requirement in order to make some the processing the product or the goods, and the secondary process is more into to support the primary process.
So primary process is a process that perform to material to give the material basic shape and function. And secondary process
To
to give to enhance a product. Maybe coating
Protect.
to protect. Casting, forging, extrusion, sheet metal working, cutting, machining
To
to give a form,
yes.
to shape material into another shape. Yeah. So, primary process is a basic function. Basic process of manufacturing process to give primary function of a product. And secondary process is assembly. Our assembly and coating, joining to make the product functionally as a whole product. Helmet, you don't need to assembly by your own. Yeah. Okay. So I think that's for today material. Is there